Hello, everybody. It's Kenneth, and after a while, I'm back with another video for you guys about blood typing and donor matching. But first, I'm sorry for the absence. We had a lot of schoolwork coming up, especially with AP exam season and stuff. But now that it's the summer, we're gonna do our best to bring more content to you guys. And we decided that we might try to specialize a little bit in what we're good at, and this is because me and Abiram, we are part of our like biomedical academy at our school. So we know some like medical stuff. So we decided that we may lean into that route for a couple videos here and there, but I would still like to continue some of the other stuff we've been doing. So watch out for that. But like I said, today we have blood typing and donor matching. Part one of this video or series, I suppose, is going to cover blood typing, and then tomorrow Abiram's going to be covering donor matching. So if you are in a Project Lead the Way program like our school is, this will be useful to you. Or if you're just like studying for some other reason, classes, college, wherever, then hopefully you find some help from this. So first, starting with blood typing, there are four blood types. There's A, B, AB, and then O. And so each blood type has different antibodies and antigens. As you can see on this chart, a blood type like the blood type A or B will have the same type of antigen in their blood. So an antigen is like an identifying marker for a cell. And you can see that, for example, this antigen here, the A antigen, is on the outside of the red blood cell. Now, antibodies, like this anti-B antibody, which is an A, they are floating around the blood and they'll attach, like, for example, if they see a B antigen in the blood, then they'll attach to that antigen and cause a response, which will cause the cells to kind of clump together. And that's like the basis of how blood typing works, but I will go into that more later. But as you can see here, like I said, the blood type has the same antigens, and then they have opposite antibodies. So, for example, A, since it's the same antigen, will have A antigens and then B antibodies. And then B will be the opposite, having A antibodies and B antigens. Now, AB, since it has both antigens, still following the trend, it's not going to have any antibodies in the plasma, which is why it, in some cases, depending on the RH, it can be a universal recipient of blood. And then O, since there's no antigens, not A or B, then there's going to be antibodies for both. Now, quickly, I'd like to go over, if you see like a pedigree for this, how it may be notated, like the blood types. So you can have sort of like a homozygous dominant blood type for A and B, and then a heterozygous one, which would be shown like I, which just shows that it's blood, and then like IA and IA. Now this shows that both of these alleles, like IA is one allele, for example, shows that both of these are type A, so the child will have type A blood. Now, for example, if it's IA and then I, well, the lowercase I, as you might guess, is recessive, so it's still going to be type A blood. So using that, you can probably figure out what the pattern is going to be, right? For B, it's just IB, IB, and this is typically how it's notated, but it can also be notated like IB down there, or maybe there's some other way your teacher, professor wants you to do it. Or this can also be IB and then a recessive one. Now, A, B, and O have to, there's only one genotype, because for AB, you have to have both A and B. So IA, IB makes AB. And then for O, you can think of O as the recessive one. So II. Completely recessive, not heterozygous. Now, you can also think like if you're provided a genotype, you can and you can identify it with like blood type, then you can also figure out like the antigens, because you see the A in the blood type, it's going to have an A antigen, and so it's going to be type A. Or you can just say it's type A, so it's going to have a A antigen. Either way, you'll get the same result. It'll be the right blood type and everything else. So going to the next slide. So there's this thing called Rh factor, which is this plus or minus in the blood type. And that's different, of course, for everybody, and it's sort of independent of like the blood type itself, like the IA, I, lowercase I, or whatever. And similar to the blood types themselves, if it's positive, then that means the Rh is like there. It's A plus. I mean, well, it just depends, right? So if you see A or any blood type and then the plus, you know that the antigen for Rh is going to be present, just like the antigen for the blood type is. But if it's minus, then it's going to be the opposite, and it's going to be the antibodies for Rh are going to be there, not the antigens. So plus is antigens and minus is antibodies. So for blood typing, and also you'll see that this says D here, and that's just like for Rh. I don't know why they say D, but if that comes up and you see it, just keep that in mind, okay? So the way this works, and this can be a little confusing at first, is you have like anti-A serum, anti-B serum, and then the anti-D or Rh serum. So what this means is it's like anti-A, it's like A antibodies, right? So anti-A is A antibodies. So let me write that down. So I'll write, just for this one, I'll write like A antibodies. A antibodies. Sorry if the handwriting is a little bad. I'm using a mouse here. So A antibodies for anti-A, and then B, you can guess that's B antibodies, and then D, which since it's Rh, it's going to be Rh antibodies. So if you think about this, an antibody reacts with an antigen, right? So if type A blood has A antigens, then which of these at the top is going to react with that blood? Well, it's going to be the A antibodies, which is the anti-A serum. So since those two are going to react, the blood is going to clump together, as you can see in this example here. Right? This blood's clumped together while this one's like still liquid. It's like all spread out uniformly. And this is called agglutination, but just think of it as like the clumping. Okay. So like sometimes, I know when I first did this, it can be a little confusing because you'd be like, well, why does that make sense? And like I said, it's just because anti-A is just A antibodies, and it reacts with the A antigens in the A blood. So just know, like, anti-A will, if it reacts with something, it'll show A, right? So it's the same letter as the N. So anti-A is A blood if it reacts. If it doesn't react, then it would either be B or O. And similar with the Rh, if Rh is present, or Rh positive blood, then we said that that means there's Rh antigens in the blood. So if the Rh antibodies, or the anti-D, is put with the blood that contains the Rh antigens, then it's going to clump together. So that's pretty much the basics. So using that, we can see like, okay, well, this one's A positive, right? Because the anti-A reacts with it, but not the anti-B. So there's no B, so it's not going to be AB. And then the RH also reacts with it. The anti-RH reacts with it, so it's also going to be positive. So A positive. And then yeah. So going on another example, well, AB positive, what do we think that's going to look like? Obviously you can see it, but if the blood type, well, I guess we can say, okay, anti-A clumps, so it must be type A or AB. Okay. Well, anti-B clumps, so since A clump too and B is clumping, then both the A and B antigens must be present in the blood. So, given that, it must be AB blood because that's the only blood type where both are present. And then we look at the RH or the D finally, and we see, oh, that also clumped, it agglutinated. Then the RH antigens must be present in the blood, so it must be positive. So this is AB positive. Okay. Now if you're doing this blood typing test in school or something, it might look like this. You'll have this tray, and credit to Maria Berger for this on YouTube. So you might have a tray like this, and what this is the anti-A serum. You can kind of see the A here. So this droplet is going to contain the A antibodies. A antibodies. And then this is the anti-B serum down here, which you should be able to see the B slightly. So this is going to be the B antibodies. And then you can see at the top right that this says, it might say D, but I think it says RH. Maybe it does say D. But either way, that's testing for the same thing. So I'll just write anti-D because that's what was on the last side. So if we put, for example, say we put blood, and you're going to put a sample of blood in each of these, right? So let's say this red's our blood, okay? Say that the blood was A positive. Predict what was going to happen. I'll give you a few seconds. Okay, so if the blood's A positive, then like we said, the anti-A is going to react with it. So it'll agglutinate here, form clumps, look like this. And then since there's no B antigens present, since it's not AB, it's only A, it's going to still be runny. It's not going to clump together in the B antibodies. So, just imagine it's like a liquid filling up this plate. And then if it's positive, like we said it was, it's still going to react with the anti-D because the antigens are present and the anti-D is the antibodies. So they're still going to react together. So this is going to clump. And then looking at this, we'd be able to tell, well, it clumps with A and it clumps with D, so it must be A positive blood. Now that's all for this video. I hope you guys found this useful. And like I said, tomorrow, Abiram will continue with like organ donation stuff, and that's more for later down the line. Like, for example, if this is the first time you've seen blood typing, I don't know if you will talk about organ donation yet, because I know that at our school, this blood typing was first brought up in our first year course, and organ typing was only this year, or organ matching. But still, this will be useful to you if you're watching blood typing, and then I'm sure the organ matching will be useful to you. So be sure to watch out for that tomorrow as well. Thank you guys and have a good day.